Okay, set 7 of the homework booklet had some interesting questions. There was a lot to kind of decode from the information and quite a few questions that could have tricked you with some of or knowing where to start. So what I'm going to do for set 7 is go through my thinking for each individual little section so that hopefully you can see how you can go about starting the question and where you can progress to get your answer. So let's have a look at the first question. We've got question 58. It's something that we haven't seen previously. We've got electrolytic cells that have been set up in a series. And the first part of the question says, use the circles provided to indicate the polarity of each electrode. Now, I've just put this little picture here on the right. You may remember from junior science, or perhaps if you're taking physics, when we draw this to show our power supply, a larger line is showing that's the positive end. So if I go back to this diagram here, I knew that my longer line was a positive, and we know that the positive end of the power supply is always connected to the positive end of my electrode. Okay, the answer's already been put in here. So this is my positive electrode. I know if I've got one positive electrode, it must then in the same cell be connected to a negative, and then it's going to be connected to the opposite charge. So it'll go positive, negative, positive, negative, positive, negative. And that's how I worked out the polarity of each electrode. Question B. It tells us that 4 moles of electrons are passed through the power supply, and it says how many electrons passes through each individual cell. So if we remember from our theory that the charge supplied by the power supply may actually differ from the charge that is received at the cell. But in this question, we aren't given any information. We're not told the charge or anything like that. So we can't work out how much charge is received by each cell. So therefore we just have to presume that the charge supplied or that passes through the power supply is going to be going through each cell. So each cell is going to have 4 moles of electrons pass through in each cell. Part 2. We've got how many moles of chlorine gas is produced in each cell. So you may have noticed when you were looking at the cells that all 3 are slightly different. So we have got copper 1 chloride, okay, and that's aqueous. We have got copper 2 chloride, so we can see the little 2 denoted for the chloride. And then we have got copper 2 chloride, but this is in the liquid form, so it's molten. So each cell is slightly different. So what I would do is I would have gotten out my electrochemical series and I would have looked at each individual cell to see is chlorine gas actually even produced in the cell, and then from there I could have worked out how many moles of the gas is produced. So if we look at this first cell, I've got copper 1 chloride. I know in this solution I'm going to have my chloride ions and I've got water present as well. So on my electrochemical series, I will highlight those. So I'm just going to worry about the chloride and the water because I know my copper is down here. It's going to be reacting. So in an electrolytic cell, it's going to be the reaction between the strongest reducing agent and the strongest oxidizing agent. Out of the chloride and the water, water is the strongest reducing agent. So this is what's going to be oxidized at the anode. We're not going to be producing any chlorine gas in that first one, okay, because the water is the strongest reducing agent. So we're not going to get any chlorine gas. So it's not going to produce anything at all. Then if we look at the second cell in the middle, again, we've got copper 2 chloride and it's in aqueous. So again, we're going to have water and chloride ions. Our water is the stronger reducing agent than the chloride ions. So again, we're not going to even be producing any chlorine gas. So it's going to be 0. The last one, we have got copper chloride, but it is molten. So because it's molten, we aren't going to have any water present. So that chloride ions are going to be oxidized and forming our chlorine gas. So let's have a go at writing out this equation. So we're going to have our chloride ions is going to be oxidized, forming our chlorine gas. That's 2 electrons. Okay, so I've gone so far. So I know that this last cell is going to be producing chlorine gas. Now I've got to work out how many mole of it it's going to be doing. So if we remember that in the previous part, we worked that 4 electrons passes through each cell. Okay, so I want to work out the number of moles. Excuse this really bad writing. Number of moles of chlorine gas. Okay, so I know that my number of electrons from the previous slide was 4. Okay, because that's how many electrons pass through each cell. Here we've got 2 electrons, so I'm going to times the 4 by half. Okay, so if you remember Faraday's second law, because I've got the 2 electrons, I need to multiply that or divide that by, multiply it by half. Okay, or divide it by 2. So I'm going to end up with 2 moles of chlorine gas being produced in this last cell. Okay, because 2 moles of electrons is used to produce 1 mole of chlorine. Okay, so if you remember Faraday's second law. The last part of the question, it tells us how many moles of metal is produced in each cell. So we're trying to work out, we've got our copper. This is our cation that's being deposited onto the cathode. So I've got, it's going to be the same equation. So I'll write this down first. Okay, here we can tell this is copper 1 chloride because chloride is an anion with a 1 negative charge. So this must be copper 1. So therefore, the number of copper is going to be equal to my number of electrons for that first one. Okay, so I'm going to have 4 moles of copper 1 formed. The second one, it's copper 2 chloride. So my number of moles for that one, if we look at this equation here, I've got 2 electrons. So I'm going to multiply, it's still got 4 electrons that have gone through the cell. So I'm going to be multiplying that by half again. So I'm going to have 2 moles of metal for copper 2 chloride, and it will be the same for the molten state. Okay, so with this question, you just had to really note, I guess, the minor details. So you had to be looking at here, noticing that this was molten, and then noticing that that first cell was copper 1 chloride, whereas the other ones were copper 2 chloride. Let's have a look at the very last part of the question. It says the whole cell is enclosed in a 100-litre container. What is the partial pressure of the chlorine gas produced if the cell is at 800 degrees Celsius? So if we remember back to Head Start, we're going to be using our ideal gas law. So PV equals nRT over V. Then what we need to do is substitute our information in. Why have I put PV? There we go. I don't know why I wrote. Yes, anyway, pressure equals nRT over V. Then we put in what we've got. So if we remember in our chlorine gas, if we go back here, we had 2 moles of chlorine gas. So we've got 2, and if you remember, R was our constant, 8.31, I lost the word. multiplied by the temperature. It was 800 degrees. So remember, we have to convert it from degrees Celsius to Kelvin. So we do 800 plus 273, which would give us 1073 Kelvin. And our volume is 100 litres. It just tells us up there. So if we plug that all into a calculator, we should come up with an answer of 178 kilopascals. And that's part C done.